Okay, cadets. So yesterday we have seen the first law of thermodynamics and little about the work done in isothermal and adiabatical processes. So as we know, there are certain applications of the first law of thermodynamics in day-to-day life, daily life, because first law of thermodynamics is related to the variety of applications in the day-to-day life. So one of the applications which we are going to discuss today. So first of all, you write down here application of first law of thermodynamics. Application of first law of thermodynamics. Okay, na? So before I could start this topic, this point, can you tell me what is the first law of thermodynamics and how did you or what did you understand out of this first law? Yes, cadet. Can anyone tell me what is the statement of first law of thermodynamics? Yes. Can anyone?
Sir, if small amount of heat is provided to the system and if the system is capable of doing the work, then the energy absorbed by the system is equal to the sum of the change in internal energy and work done.
Exactly, wonderful. Okay, so as we know, as we have studied also, suppose if we provide small amount of heat energy to the system and system is capable for doing some work. I repeat, system is capable of doing some work, then amount of heat energy absorbed by the system. So here Q is the amount of heat energy is absorbed by the system. It's not provided to the system. We may provide a lot of energy to the system, but system absorb only Q amount of heat energy, right? So Q is amount of heat energy absorbed by the system is equal to sum of increase in its internal energy plus external work done or mechanical work done. Means in short, we can say that whatever amount of energy we are going to supply to the system and whatever amount of energy is being absorbed by the system, okay, out of that energy which is being absorbed by the system, some part of energy will be utilized to increase its internal energy, means to increase its temperature, to increase the average kinetic energy and the potential energy of the molecules inside the cylinder, and the remaining half of the energy must be utilized for external work done, for expansion process. This is all about the first law of thermodynamics, right? So now we are going to discuss the application of first law of thermodynamics. That is wonderful application we have with us, that is heat engine. Okay, wait, give me 1 minute only. Okay, so right, so this is all about the first law of thermodynamics. Now we are going to discuss the application of first law of thermodynamics, that is a heat engine. So you write down the name first, heat engine. Okay, so first of all, let me know the moment I wrote the word on the screen, heat engine. So what are the things that strikes to your brain? What are the different things comes in your brain, Bacho? The moment I write engine word on the screen, can you tell me what is the first thing which has strike to your brain the moment I written the engine word on the screen? Yes, cadets.
A system which drives the car or a vehicle or the machine.
Exactly. System which drives the car, vehicle, or machine. Or can we say that?
Which supports the
Yes, yes. Go ahead. Yes. Yes, Anujesh, would you like to say something? Okay. So that's what we are going to discuss today, the heat engine. And this is the as I told you, this is the application of first law of thermodynamics, right? So first of all, as we are going to discuss the any device, so as I told you, if you discuss the device with the help of four major components of it, four major parameters of it. So first of all, we are going to discuss what is the definition of heat engine. Okay, first of all, we'll discuss what exactly the heat engine, what's the definition of heat engine. Okay. Secondly, we'll discuss on what principle heat engine works, what is the principle of heat engine. Okay. And thirdly, we'll see what is the construction of heat engine. That is very important point. Construction of heat engine, HE. Okay. And last, we'll see the working and efficiency. So first of all, definition is very easy, bacho. Heat engine, it is a device. Try to understand it very carefully. Heat engine, it is a device which converts heat energy, into mechanical energy. Heat energy into mechanical energy, right? Means suppose the heat energy is generated or heat energy taken from the source, which can be converted into mechanical energy in the cyclic process. So this is cyclic process, bacho. Okay, so I'll tell you what exactly the cyclic process. Cyclic process means what? If you draw the graph, okay, or if you see, can you tell me any cyclic process around you? Yes, cadets. Yes, dear cadets, can you tell me any cyclic process around you in day-to-day life?
Rain cycle.
Okay, rain cycle, very good, wonderful example. Okay, so cyclic process means what? Suppose if you take the example of piston also, if you take the example of piston, कि जैसे हमने देखा था example, consider cylinder which contains a large number of molecules, okay, of gas and which is enclosed with a weightless, frictionless and movable piston, right? So now suppose if initially the piston was at position V1 and after giving some heat energy Q to the system, definitely there will be the expansion. Okay, so some work is done in order to happen that expansion. So later on, this piston moves to position V2 from its original position V1, right? Means in this case, we just got the expansion process done with the help of heat energy. And then suppose if you remove that heat energy again, or that heat energy somewhere you can utilize it, okay, or work done produced during this process, if you utilize it, then again it will attain its initial position. Are you getting my point? Means initially the piston was at position V1 or at volume V1. If you provide some heat energy due to the random death of the molecule, due to increasing its internal energy, due to increasing its expansion process, work done will cause, and work done leads the expansion of the gas from V1, initial volume V1 to final volume V2. ठीक है ना? But again it will come its original position from V2 to V1. So it is called a cyclic process, and this cycle keep on going. Okay, so unless and until we stop giving the heat energy, the cycle will not stop. So this is called a cyclic process. Means piston will move from V1 to V2, again it will return from V2 to V1, and then again V1 to V2, V2 to V1, and this is what the heat engine works. If you see the diesel engine in the vehicles, if you see the petrol engine in the vehicles, so block piston, have you heard about the blocks, pistons, cylinders? So this is what exactly happens inside the cylinder. Okay, we'll discuss in detail in construction and working of heat engine. But cyclic process means what? The change in internal energy is zero. Suppose initially temperature was T1, then it raised to T2, then again drop down to the T1. Means if you see the graph, okay, pressure against volume. So we'll get this graph, bacho. We'll get this type of graph. Here actually work done is zero. System causes no work done in this process. But if you talk about in terms of heat, suppose if you provide Q amount of heat, then as internal energy is zero, So we can write from this equation Q is totally converted into work done. समझ में आ रहा है? Means whatever amount of heat energy we are going to supply to the system, that entirely converted into work done. This is called a cyclic process. मतलब एक पूरा साइकिल वहां पे कंप्लीट होता है. पिस्टन V1 से शिफ्ट होकर V2 तक जाता है, then again it got shifted to the V1, then again V1 to V2, V2 to V1. So in this way it carried out. Clear बच्चों? What is cyclic process? In short we can say reversible process. In short we can say reversible process, the process which can be made to proceed in reverse direction also. Means allow this gas expand slowly and then again it will compress from V2 to V1. Understood? समझ में आ रहा है बच्चों? Is that clear what I am telling you? So एक छोटा सा पॉइंट क्लियर हो गया. What is cyclic process? Yes बच्चों? Yes or no? Fast. We have to do a lot of point today. अरे if yes say yes, if no say no.
सर आपने सर कुछ ज्यादा ही इधर एक्सप्लेन कर दिया इस टॉपिक, मतलब इस पॉइंट को.
ओके सो ज्यादा एक्सप्लेनेशन हो गया, ज्यादा डिटेल में चले गए. ठीक है. इन शॉर्ट आई विल एक्सप्लेन, फॉरगेट अबाउट दिस ग्राफ. ओके, सो सिंपली देखो साइक्लिक प्रोसेस क्या होती है. मतलब इट इज अ वन साइकिल. मींस सपोज इनिशियली पिस्टन वाज एट पोजीशन V1, means V1 is the initial volume. If we provide some heat energy to the piston or cylinder, then its internal energy will increase and it leads expansion of the gas. तो expansion हो जाएगा, work done मिलेगा, then piston will move from V1 to V2. Okay, अगर यहाँ पे हम work done extract करेंगे, suppose this piston is connected somewhere to the shaft and series of gears, okay, or gear is connected to the wheel, then wheel will rotate and that energy we can extract from the piston, so it will lose energy, it will convert energy into kinetic energy of the wheel. So again it will drop down from V2 to V1, then again it will take energy from the heat, again it will come to the V2, then again V2 to V1, V1 to V2. Are you getting my point? So this cycle keep on going, okay, unless until we stop giving the heat energy to the system. Okay, this is called a cyclic process. मतलब एक complete cycle होता रहता है. Understood? And this is the definition. हाँ, yes, Vaishnavi.
Sir, means from heat energy to mechanical energy and again from mechanical to heat.
हाँ, see, we cannot say here again from mechanical to heat because we cannot convert entire heat energy into mechanical energy. वहाँ पे enthalpy आ जाता है. Okay, in chemistry you must have learned the process of enthalpy, disorder. Okay, वहाँ पे enthalpy आ जाता है because क्या होते हैं, use न होने वाली जो energy होती है ना वो enthalpy में convert हो जाती है. Clear? And there is no heat engine as such or as of now which converts 100% heat energy into mechanical energy. Clear? Here what we are going to discuss, cyclic process में वो convert हो जाती है heat energy into mechanical energy. Are you getting my point? I am not telling you this is a cycle कि heat energy is converted into mechanical, then again mechanical into heat. No. Try to understand. I am telling you heat energy gets converted into mechanical energy under the cyclic process. Cyclic process मतलब सिलेंडर के अंदर ही साइकिल होता है और वहां से जो मैकेनिकल एनर्जी मिलती है वो कन्वर्ट करते हैं हम फॉर द काइनेटिक एनर्जी ऑफ द व्हील. समझ में आ रहा है? मींस हियर, यस वैष्णवी, डिड यू अंडरस्टैंड?
Yes, means sir work done में cyclic process हो रहा है.
हाँ, वर्क डन में साइक्लिक प्रोसेस हो रहा है. Here you should not understand in this way कि heat energy is mechanical then again mechanical into heat. No. Heat, what is the definition of heat engine? Simply heat engine converts heat energy into mechanical energy in cyclic process. मतलब whatever heat energy is going to convert into mechanical process, no, it will be in the cycle. मतलब cycle in the sense of work done का cycle यहाँ पे होता है. That's what I told you. Initially यहाँ पे small explosion होगा, then piston will move up, then mechanical energy will be extracted by the shaft and series of gears to the wheel, and then again piston will move down, it will come down, then again explosion, again heat will cause, then piston will move upwards. Are you getting my point? So cycle जो होगा वो piston के अंदर होगा. Understood?
Yes sir.
Okay, so this is all about the cyclic process. Okay, ठीक है, ये छोटा सा point था. So once again, heat engine, it is a device which converts heat energy into mechanical energy in the cyclic process, right? Now we'll see the principle of heat engine. Same, it works on the first law of thermodynamics, cadet. It works on first law of thermodynamics. Okay, means in simple, in short, we can say whatever amount of heat energy we are going to provide to the system, and if system is capable of doing some work, then amount of heat energy absorbed by the system will be utilized for two reasons. One, to increase its internal energy, and second, to do the work done. But heat engine में होता क्या है देखो, as it is cyclic process, as I told you, as it is cyclic process, और cyclic process की characteristics क्या होती है? What is the main characteristics of cyclic process? Change in internal energy is always zero. समझ में आ रहा है? In cyclic process, change in internal energy is zero because वहां पे temperature change ही नहीं होता. Because suppose initially the piston at position V1, थोड़ा सा हीट उसको दोगे तो ड्यू टू दैट हीट पिस्टन विल मूव टुवर्ड्स V2, देन अगेन हीट कम होगी तो और नीचे आएगा, अगेन हीट ज्यादा होगी तो और ऊपर जाएगा. आर यू गेटिंग माय पॉइंट? दैट्स व्हाई इट इज साइक्लिक प्रोसेस, एंड इंटरनल एनर्जी का चेंज जो होता है साइक्लिक प्रोसेस में वो कितना होता है? जीरो होता है. अंडरस्टूड? सो फाइनली we'll get Q is equal to W only, but there will be the energy loss. Clear? Yes, cadets. So tell me, did you understand the definition and principle of the heat engine?
Yes, sir.
Okay. ठीक है. Once again I'll repeat. Heat engine, it is a device which converts heat energy into mechanical energy in the cyclic process. It works on the principle of first law of thermodynamics, that is, amount of heat energy supplied to the system and the system is capable of doing some work, then amount of heat energy absorbed by the system is equal to sum of change in internal energy plus external work done. But as we know, in cyclic process, a change in internal energy is zero. So whatever energy is going to absorb, or whatever energy is being absorbed by the system, it will be utilized for the work done only. और कितना यूज करेगा वो आगे देखेंगे. ठीक है, इफिशिएंसी में उसका. ठीक है. नाउ विल डिस्कस द कंस्ट्रक्शन ऑफ हीट इंजन. सबसे इंपॉर्टेंट पॉइंट बच्चों, कंस्ट्रक्शन ऑफ हीट इंजन. सो मेनली अगर हम देखें, सो कंस्ट्रक्शन ऑफ हीट इंजन इज बेसिकली डिवाइडेड. हाँ बोलो.
यहाँ पे इंटरनल एनर्जी इंक्रीज हो रही है और डिक्रीज हो रही है, इसकी वजह से हमने इसे जीरो लिया.
यस, क्योंकि
But
इंक्रीज
sir,
ही नहीं हो
work
रही है. आई टेल यू, वेट. तो वो क्यों इंक्रीज नहीं हो रही है पता है क्या? इसका रीजन है, व्हेन द पिस्टन वाज एट पोजीशन V1, राइट, एंड इफ यू प्रोवाइड स्मॉल अमाउंट ऑफ हीट एनर्जी थ्रू द फ्यूल और वर्किंग सब्सटेंस, देन दैट हीट लीड्स टू द एक्सपेंशन. वो एक्सपेंशन कॉज करेगा. ठीक है. रीजन, जो हीट जनरेट होगी वो पूरी की पूरी एक्सपेंशन के लिए यूज होगी, तो टेम्परेचर बढ़ेगा उसका? नहीं बढ़ेगा. Are you getting my point? And if temperature is not going to increase, then will not get any change in internal energy here. Understood, Vaishnavi?
Yes, sir.
But यहाँ पे और एक डाउट आप पूछ सकते हो कि सर, कि as you are saying the internal energy is not going to increase, temperature increase नहीं होगा, तब इंजन गर्म क्यों होता है? Are you getting my point? तो इंजन गर्म क्यों होता है? The reason is the friction between, because we don't have frictions, or we don't have pistons which has zero frictional or zero coefficient of friction. समझ में आ रहा है? And due to that friction, क्योंकि क्या होता है, इसलिए that is, it is advisable to use or to change the oil regularly of the vehicles. कि अगर ऑयल अच्छा होगा तो फ्रिक्शन हम रिड्यूस कर सकेंगे, बट वी आर नॉट एबल टू रिड्यूस 100% फ्रिक्शन इन द ऑयल. तो ऑयल का फ्रिक्शन हम 100% रिड्यूस नहीं कर सकते, and that is the reason why there is a small friction and the heat energy will be lost. It loses its energy in the form of heat. Again, वहां पे वो ड्रॉबैक है उसका. क्लियर वैष्णवी?
Yes, sir.
Yes. So now, yes cadet, सबको समझ में आ रहा है? Hope you are understanding. Now, construction of heat engine. And as I told you, construction of heat engine is mainly divided into three components, three major components. First, source. ठीक है. Second, working substance. ठीक है. And third one, sink. I repeat, first source, second working substance, and the third is sink. ठीक है? Now we'll discuss in detail. Now just imagine, let me draw the figure here. Okay. Suppose, just imagine that this is a source, okay, and this is a sink. Okay. And here is the working substance. This is a working substance, right? Clear? So here deliberately I am making it colorful to create the interest among you. So this is source, this is working substance, and this is sink, right? Now we'll step by step we'll discuss what exactly the source, what exactly the working substance, and what is sink, right? So first of all, I'll give the explanation, or I'll just give the brief explanation of the source. So basically we are going to discuss source in 2 points, okay, and sink also in 2 points. So first of all, I'll explain what is source and what is sink. Try to understand, cadet. Okay. So what is source? Dekho, source is the hot reservoir. First of all, source is hot reservoir, okay, at temperature T1, at temperature T1. And second point, it has high thermal or infinite thermal ability or capacity, so that we can take out any amount of heat. We can take out any amount of heat, okay, without increasing its temperature. I repeat, source is the hot reservoir at temperature T1, right? And it has high infinite or infinite thermal ability. उसको infinite thermal ability होती है, कितना भी हीट उससे निकालो, उसके टेम्परेचर पे कोई भी चेंज नहीं होने वाला है. समझ में आ रहा है? उसको सोर्स बोलते हैं. लाइक सन, कितना भी हीट उससे निकालो, कितना भी लाइट निकालो, ओके, is it going to change its temperature? Is it going to change its capacity of giving light? Yes, cadet. No, na. That is why it is called a source of light and source of heat. Okay. So same way in heat engine, what is source? First thing, it is a hot reservoir at temperature T1. It is a hot reservoir at temperature T1, and it has infinite thermal ability, so that we can take out any amount of heat from it without decreasing its temperature. Are you getting my point? Yes, students. Did you understand the 2 points which I told you regarding the source?
Yes, sir.
Okay. Similarly, we'll discuss what is sink. इसके उल्टा होता है. Sometimes we call it sink as a wash basin. Basin को हम sink बोलते हैं. Do you remember it? Do you know?
Yes, sir. आपने बताया था last time.
हाँ.
बताया था क्लास में.
Yes. Already we have discussed this in the classroom, physical classroom.
Yes, sir.
So sink मतलब होता क्या है? उसमें कितना भी पानी डालो wash basin में, वो पानी ऊपर नहीं आता, तो पानी गायब हो जाता है, तो उसको बोलते हैं सिंक. Similarly here, sink is the cold reservoir. What is sink? Sink is the cold reservoir, okay, at temperature T2. मतलब इसका temperature T2 होता है, and again it has infinite thermal ability or infinite thermal capacity, so that we can give any amount of heat, give or add up or put any amount of heat, okay, without changing its temperature. उसको कितना भी हीट दे दो, वो अपना टेम्परेचर कभी भी चेंज नहीं करेगा. फॉर योर काइंड इंफॉर्मेशन, दैट इज कॉल्ड अ सिंक. समझ में आ रहा है? सो वंस अगेन, व्हाट इज सोर्स? इट इज द हॉट रिजर्वायर एट टेम्परेचर T1, and it has infinite thermal ability, so that we can take out any amount of heat without changing its temperature, without decreasing its temperature practically, right? And what is sink here? Again same, it is a cold reservoir at temperature T2, and again it has also high thermal ability, infinite thermal ability. We can give it any amount of heat without increasing its temperature. कितना भी हीट दे दो, उसका टेम्परेचर नहीं बढ़ेगा. देखो वंस अगेन, सोर्स मतलब एक हॉट रिजर्वायर होता है, उसका टेम्परेचर T1 होता है, उससे कितना भी हीट निकालो उसका टेम्परेचर नहीं कम होने वाला है। सिमिलरली सिंक कोल्ड रिजर्वायर होता है, ओके, उसका टेम्परेचर T2 होता है और उसको कितना भी हीट दे दो उसका टेम्परेचर बढ़ने वाला नहीं है। So hope I am very clear with source and sink. Yes, cadets, is that clear?
Yes, sir.
Okay, now we'll discuss working substance. What exactly the working substance? A working substance hota kya hai? Working substance hota kya hai? So working substance may be, it may be, देखो आप कैसे लिखना, it may be solid, it may be liquid और gaseous. समझ में आ रहा है? वो सॉलिड हो सकता है, लिक्विड हो सकता है और गैस भी हो सकता है। एंड इट एक्चुअली डज द वर्क डन फॉर द हीट इंजन। बच्चों, जो वर्क डन वाला काम है ना, जो वर्क डन करने का, एक्सपेंशन होने का काम, वो इसकी रिस्पॉन्सिबिलिटी होता है। मींस वर्किंग सब्सटेंस इट मे बी सॉलिड, लिक्विड और गैसेस एंड इट एक्चुअली परफॉर्म्स द मैकेनिकल वर्क डन बाय एब्सॉर्बिंग हीट एनर्जी फ्रॉम द सोर्स। ये दो लाइन आपको याद रखने हैं, इसके भी 2 पॉइंट याद रखने हैं। देखो फर्स्ट लाइन आपको क्या लिखना है, व्हाट आर यू सपोज टू राइट? फर्स्ट पॉइंट, इट मे बी सॉलिड, लिक्विड और गैसेस। ओके, वर्किंग सब्सटेंस इट मे बी सॉलिड, लिक्विड और गैसेस। एंड सेकंड लिखना है, एंड इट एक्चुअली परफॉर्म्स द वर्क डन, इट एक्चुअली परफॉर्म्स द वर्क डन बाय एब्सॉर्बिंग सम हीट एनर्जी फ्रॉम द सोर्स। यस कैडेट्स, क्लियर हो गए 2 पॉइंट वर्किंग सब्सटेंस के? ये स्टूडेंट्स बोलो, हाँ अरे बोलो, कुछ तो बोलो, से यस और नो।
रिपीट कर दो सर, सेकंड पॉइंट।
हाँ यस, आई कुडंट हियर यू प्रॉपर्ली।
सर सेकंड पॉइंट रिपीट करना।
ओके ओके, आई विल रिपीट, डोंट वरी, गुड। सो फर्स्ट पॉइंट व्हाट डिड आई टेल यू? इट मे बी सॉलिड, लिक्विड एंड गैसेस, दैट्स इट। सेकंड पॉइंट क्या है? It actually performs the work done. It actually performs the work done. But कैसे perform करेगा work done? By absorbing some heat energy from source. By absorbing some heat energy from the source. Clear? I repeat, second point. It actually performs the work done by absorbing some heat energy from the source. Clear?
Yes sir.
Yes, sir.
Wonderful. And one more line you add it. For example, अभी example क्या हो सकता है? If we consider, यहाँ पे दिखता है example. If you consider the diesel engine, you know diesel engine कार में यूज किया जाता है. If you consider diesel engine, so diesel engine में क्या fuel, क्या working substance होता है? Working substance WS. It will be the mixture of, वो क्या होता है? It is a mixture of diesel वेपर्स, मिक्सचर ऑफ डीजल वेपर्स प्लस एयर। समझ में आ रहा है? मतलब अगर हम बात करें डीजल इंजन की, तो उसमें डीजल वेपर प्लस एयर का मिक्सचर स्प्रे किया जाता है। ओके, इफ यू टेक सेकंड एग्जांपल ऑफ पेट्रोल इंजन, सो कैन यू टेल मी व्हाट विल बी द मिक्सचर व्हिच बीइंग यूज्ड इन द पेट्रोल इंजन इन द टू व्हीलर्स स्पेशली?
पेट्रोल वेपर
प्लस एयर।
Exactly, wonderful. Petrol vapors plus air. Third example, petrol engine हो गया. Third example, we can write the steam engine. Steam engine में क्या यूज होता है पता है आपको?
वाटर वेपर।
हाँ, yes, it uses steam as a working substance. Only steam as a working substance. ठीक है? तो देखो यहाँ पे I already discussed you the 3 point. We had a discussion regarding the 3 points: source, working substance, and sink. And again 3 point in the working substance. Once again, I explain, I repeat, working substance. Working substance, first point देखो, it may be liquid, solid or gaseous state. Second point, it actually performs the work done by absorbing some amount of heat energy from the source. And third point, example, if you consider diesel engine in the vehicles, then working substance in the diesel engine will be the mixture of diesel vapor plus air. Okay, in steam engine it will be the steam, and in petrol engine it will be the mixture of petrol vapors plus air. So yes cadet, tell me, am I very clear with the construction of the heat engine? कोई doubt है construction में?
No sir.
Okay, wonderful. So we'll go ahead with the working now. अब working के साथ आगे जाएंगे. So let me erase this. थोड़ा कलरफुल अभी उसको academically strong बनाते हैं, as we are going to write this in the your paper examination paper. For NDA GAT it will come objective type, but for theory examination definitely you are going to write it in the question answer sheet. ठीक है, तो देखो first thing source, ठीक है, then sink, ठीक है, and working substance. This is working substance. So I'll write here. So first, okay, once again, source is a hot reservoir at temperature T1 and it has high thermal ability so that we can take out any amount of heat without decreasing its temperature. Then sink, it is a cold reservoir at temperature T2. Okay, so T1 is greater than T2 here. Okay, because this is hot and this is cold reservoir, and it has again high thermal ability, sink, so that we can add up or give any amount of heat energy to the sink without increasing its temperature, and this is working substance. Okay, अभी बोला मैंने डीजल इंजन में वो हो सकता है मिक्सचर ऑफ डीजल वेपर्स प्लस एयर, स्टीम इंजन में स्टीम हो सकता है. ठीक है, अब डिस्कस करेंगे हाउ डज इट वर्क, एक्चुअली वर्किंग कैसे होता है हीट इंजन का. ठीक है ना, तो कॉन्सेंट्रेट नाउ, this is very easy, and after this I'll be showing you one video, wonderful video, so that you can understand also. ठीक है, so what is the working of this, you just check it out. So what is the working, we'll discuss now. So first case, first point आपको क्या लिखना है, working substance absorb, देखो क्या करता है working substance absorb small amount of heat energy from source. I repeat, working substance absorbs Q1 amount of heat energy at temperature T1 from source. ठीक है, I repeat, working substance initially absorb Q1 amount of heat energy at temperature T1 from source or from hot reservoir. Then whatever amount of heat energy is absorbed by the working substance, अभी देखो working substance क्या करेगा, it will absorb some energy from the hot reservoir, and whatever amount of energy is absorbed by the working substance, part of heat energy will be utilized for work done. तो थोड़ा सा एनर्जी किसमें यूज किया जाएगा, एक्सटर्नल वर्क डन के लिए यूज किया जाएगा. ठीक है ना, तो थोड़ा सा एनर्जी कहां पे यूज किया, ऑलमोस्ट 90% हम बोल सकते हैं एनर्जी किसमें यूज किया. जस्ट इमेजिन दैट 90% पे नहीं होता है. ठीक है, सो 90%, if you just for sake of example, if you say 90% energy is utilized to do the work done, तो remaining energy कहाँ जाएगी, remaining energy will be rejected towards sink. समझ में आ रहा है, the remaining energy, heat energy is Q2 is rejected towards sink at temperature T2. समझ में आ रहा है, अभी देखो थोड़ा सा elaborate करता हूँ इसको. जो वर्किंग सब्सटेंस होता है सिलेंडर, अभी देखो यहाँ पे मैं ब्लॉक डायग्राम आपको निकाल के दिखाता हूँ. दिस इज अ सिलेंडर. ओके, उसमें थोड़ा सा स्पेस होता है. जस्ट इमेजिन दैट, इसके ऊपर पिस्टन हमने कनेक्ट किया है. दिस इज अ पिस्टन, तो पिस्टन अप डाउन करेगा ये, राइट. तो जैसे ही स्मॉल एक्सप्लोजन होगा उसमें, सी नाउ दिस इज अ पिस्टन. नाउ अब होता क्या है देखो, व्हेन द फ्यूल वेपर और डीजल वेपर प्लस एयर मिक्सचर केम इनसाइड and there will be one spark, तो वहां पे एक स्मॉल एक्सप्लोजन होता है. there will be a small explosion. ठीक है, an amount of heat energy generated in this, तो this will be act like a source. तो वहां पे टेम्परेचर T1 होता है. ठीक है, वो सब अंदर ही होता है. इसको इसलिए इसको बोलते हैं इंटरनल कंबशन. ठीक है, इंटरनल कंबशन इंजन. I'll tell you what is internal external also after this. ठीक है, so small amount of heat is being generated and due to that heat the expansion causes, expansion होता है. समझ में आ रहा है, आर यू गेटिंग माय पॉइंट. वो एक्सपांशन होता है यहाँ पे एंड पिस्टन ऊपर जाता है, पिस्टन मूव्स अपवर्ड. ठीक है, देन इस पिस्टन को एक शाफ्ट कनेक्टेड होता है, शाफ्ट. ठीक है, एंड दिस शाफ्ट इज कनेक्टेड टू द सीरीज ऑफ गियर्स, सीरीज ऑफ गियर्स, एंड सीरीज ऑफ गियर्स से कनेक्टेड होता है व्हील को. किसको कनेक्टेड होता है, व्हील को कनेक्टेड होता है. ठीक है, सो फाइनली द मैकेनिकल एनर्जी, द वर्क डन प्रोड्यूस्ड ड्यू टू द हीट एनर्जी इज ट्रांसफर्ड टू द व्हील. तो व्हील काइनेटिक एनर्जी में उसको रोटेट करेगा और काइनेटिक एनर्जी विल बी यूटिलाइज्ड इन टर्म्स ऑफ रोटेशन ऑफ द व्हील. क्लियर. सो वंस अगेन, दिस वर्किंग सब्सटेंस एक्सप्लोजन होने के बाद यहाँ पे सोर्स क्या होगा? सोर्स इज एक्सप्लोजन ऑफ द पेट्रोल और डीजल, एंड अमाउंट ऑफ हीट जनरेटेड, स्मॉल पार्ट दैट इज Q1 अमाउंट ऑफ हीट एनर्जी विल बी एब्सॉर्ब बाय द वर्किंग सब्सटेंस. वर्किंग सब्सटेंस मतलब आपका ये, ठीक है ना? तो वो क्या होगा देन? दिस एनर्जी विल बी यूटिलाइज्ड फॉर द एक्सटर्नल वर्क डन, ठीक है? एंड थोड़ा सा एनर्जी जो वेस्ट होगा इट विल बी रिजेक्टेड टुवर्ड्स सिंक. सिंक मतलब हमारा एटमॉस्फेयर, जो साइलेंसर से धुआं बाहर आता है. Have you seen that some smoke is coming out, carbon is coming out from the silencer, and if you touch it, you can feel the heat in it. Can you see that? Can you feel it? Experience it, that heat? Okay, that is the rejected heat. वो होता है हमारा Q2, वो रिजेक्ट करता है हीट इंजन, हीट एटमॉस्फेयर में, ठीक है ना? क्लियर? मतलब कभी भी ऐसे नहीं होता कि वहां से धुआं बाहर नहीं आता या हीट बाहर नहीं आती. मतलब ऑलमोस्ट 10-20% हीट बाहर आती है, मतलब एक्सलेंट कंडीशन पे, बट उतना ही, उससे ज्यादा ही होता है वहां पे. अंडरस्टूड? सो दिस इज ऑल अबाउट वर्किंग. I'll once again explain the working बच्चों फॉर योर काइंड इंफॉर्मेशन. लिसन, क्या लिखना है आपको वर्किंग में? वर्किंग सब्सटेंस विल एब्सॉर्ब Q1 amount of heat energy at a temperature T1 from the source. Then amount of heat energy absorbed by the working substance, part of it will be utilized for the external work done to perform the work done. And remaining amount of heat energy Q2 will be rejected towards the sink at temperature T2. Clear? मतलब यहाँ पे देखो हम इसको एनर्जी कितना दे रहे हैं, what amount of energy we are providing to the system Q1, उसमें से थोड़ी वर्क डन के लिए यूज हो रही है, और रिमेनिंग विल बी रिजेक्टेड टुवर्ड्स द सिंक. मतलब दिस विल बी द इक्वेशन यहाँ पे आएगा. एंड फ्रॉम दिस वी कैन कैलकुलेट द नेट वर्क डन. जो टोटल वर्क डन आपको मिलेगा वो कितना आएगा? amount of heat energy received and amount of heat energy lost or rejected toward the sink. So in this way we'll get the work done formula also here. So Q1 minus Q2 will be the net work done in the heat engine. Yes बच्चों, अभी is that clear? Clear है?
Yes sir.
Okay, now we'll see. And यहाँ पे होता है क्या? देखो once again वर्किंग में देखो होता क्या है. I repeat again and again, I am repeating this because आपको अच्छे से समझ में आना चाहिए. देखो दो ही पॉइंट आपको इसमें लिखने हैं, दो ही पॉइंट आपको प्रिपेयर करने हैं फॉर योर एग्जामिनेशन. फर्स्ट, ट्राई टू अंडरस्टैंड वर्किंग सब्सटेंस विल एब्सॉर्ब Q1 अमाउंट ऑफ हीट एनर्जी एट टेम्परेचर T1 फ्रॉम द सोर्स, एंड वॉट एवर अमाउंट ऑफ एनर्जी इज एब्सॉर्ब बाय द वर्किंग सब्सटेंस, आउट ऑफ दैट और पार्ट ऑफ दैट एनर्जी, some part of that energy will be converted into work done, converted into expansion of the piston. And remaining amount of heat energy Q2 will be rejected or will be escaped or will be released in the atmosphere, that is sink at temperature T2. ठीक है? Clear? For example, in diesel engine, I repeat, for example, in the diesel engine, okay, the heat energy caused due to the explosion of the fuel, out of that small heat energy is absorbed by the piston, or here we can say cylinder does the work done. I repeat, cylinder does the work done for the heat engines, and then piston moves up and down. So in this process, the whatever mechanical energy is being generated, it is transmitted towards the wheel through the series of shaft and gear. Already I have shared the notes on the group. ठीक है? So in this way it works. But इसमें एक point आपको समझ में लेना, what is 4-stroke engine and what is 2-stroke engine. I repeat, what is 4-stroke engine? 4-stroke engine होता क्या है और 2-stroke होता क्या है? Okay, so 4-stroke engine means what? I repeat, what is 4-stroke engine? Means once explosion happens in the cylinder, then a piston 4 बार ऊपर जाके नीचे आता है. It performs the cycle 4 times. एक बार ऊपर गया नीचे आ गया, then ऊपर नीचे ऊपर नीचे ऊपर नीचे से 4 times it performs the cycle. Understood? In 2-stroke engine, one explosion happens, then it performs twice. So did you understand what exactly the difference between 4-stroke and 2-stroke engine, cadets?
Yes, sir. Sir, it depends on fuel.
Fuel, it depends on the fuel and the cylinder capacity. Fuel पे नहीं है, क्योंकि see what happened, you know, we are using same fuel in the 2-stroke and 4-stroke engine, but efficiency of 4-stroke is always greater. Why? Because 4-stroke engine का जो cylinder है, it is designed in a such a way so that it utilize its energy in the optimum or optimum amount. समझ में आ रहा है? मैक्सिमम एनर्जी वो यूटिलाइज करता है, क्योंकि एक बार एक्सप्लोजन हो गया, सेम एक्सप्लोजन हैपेंस इन द टू स्ट्रोक आल्सो, बट इसके इंजन का डिजाइन ऐसे नहीं होता, वो सीसी में हम काउंट करते हैं, सीसी सेंटीमीटर क्यूब, ठीक है, 125 सीसी, 150 सीसी, 350 सीसी, तो अलग अलग आउटपुट उसके होते हैं, राइट। सो 4 स्ट्रोक होगा तो एक बार एक्सप्लोजन होने के बाद वो पिस्टन 4 बार ऊपर जाएगा, 4 बार नीचे आएगा, 4 साइकिल्स विल गेट इट, बट अगर 2 स्ट्रोक होगा देन विल गेट ओनली 2। अंडरस्टूड कैडेट? क्लियर?
Yes.
यस सर।
ओके, ठीक है। नाउ नेक्स्ट इफिशियंसी।
सर
हाँ बोलो बोलो, डाउट होगा तो यू कैन आस्क।
sir to activate source sir what we are giving sir means
स्पार्क देते हैं विद द हेल्प ऑफ बैटरी, नो वी गिव अ स्पार्क देते हैं, और वहां से पेट्रोल का तो डीजल वेपर आ रहा है, सो इफ यू गेट द स्पार्क देन वो एक्सप्लोजन होता है। क्लियर?
yes sir
गॉट इट?
self लगाते हैं sir that और सब sometimes we rotate wheel sir also
यस यस, समटाइम्स वी रोटेट व्हील आल्सो, क्योंकि पिस्टन स्टार्ट होना चाहिए ना, प्रोसेस स्टार्ट होना चाहिए। इफ यू रोटेट द व्हील, अगर गियर में होगी कार आपकी तो ये पिस्टन ऑटोमेटिकली स्टार्ट हो जाएगा, बिकॉज समवेयर पिस्टन्स आर कनेक्टेड टू दी व्हील्स। क्लियर? और जब हम न्यूट्रल करते हैं इसका मतलब क्या है? वी डिस्कनेक्ट द, सपोज अगर इफ द कार इज हैविंग 4 स्ट्रोक इंजन एंड इफ यू न्यूट्रल इट, then it sees or it disconnect the contact between piston and the wheel. तो गियर का काम होता है कॉन्टैक्ट डिस्कनेक्ट कर देते हैं। ड्यू टू दैट रीजन व्हील्स आर रोटेटिंग, कीप ऑन रोटेटिंग, ओके, बट द पिस्टन विल नॉट मूव इन दिस केस।
yes sir
क्लियर? सो विल सी नाउ इफिशिएंसी नाउ। सो
सर जब हम
हाँ यस बच्चों बोलो।
सर बाइक की सर जब स्पीड बढ़ाते हैं तो उसमें सर एक्चुअली हम करते क्या है, मतलब पेट्रोल वेपर सर इंक्रीज करते हैं क्या?
नहीं, आई कुडंट हियर यू, थोड़ा स्लोली बोलो। हाँ
नहीं sir he want to ask that sometime when we accelerate bike sir then what we do sir
व्हेन वी हैव सिलेक्टेड,
when we accelerate sir उसकी स्पीड बढ़ाते हैं सर जब
हाँ
velocity
तो ऐसे लिसन, सब जो खेल है ना बच्चों, एवरीथिंग इज डिपेंड्स ऑन द पिस्टन नाउ। सो इफ यू एक्सेलरेट द कार, द मोर फ्लो ऑफ पेट्रोल विल कम डाउन इन द इंजन, राइट? So more explosion, more amount of heat energy, more work done, more mechanical energy, more rotation of the speed, rotation of the wheel. Clear?
Yes sir.
Understood? So if you accelerate, then more petrol will come, more diesel vapors will come down, because somewhere the wire of accelerator is somewhere connected to the carburetor, if you see. Clear?
yes
Okay. Now we'll see the next point of this. So we have done with the definition, principle, construction, then working also, and at last we'll see, just take a screenshot of this screen. So at last we'll see the efficiency. ठीक है? तो देखो यहाँ पे efficiency of the heat engine हम discuss करेंगे. What is efficiency? How efficient is the heat engine? So write down efficiency of the heat engine. Efficiency of heat engine. ठीक है? व्हाट एग्जैक्टली द इफिशियंसी? तो देखो यहाँ पे हाउ डू वी कैलकुलेट द इफिशियंसी ऑफ द एनी डिवाइस बच्चों, कैसे निकालते हैं? तो हम ऐसे ही निकालते हैं ना इफिशियंसी। अगर आपको निकालनी होगी, इसको एक सिंबल देंगे इफिशियंसी को, सपोज ईटा बोलेंगे इसको। सो हाउ डू वी कैलकुलेट इफिशियंसी? देयर इज वन कॉमन फॉर्मूला बच्चों, आउटपुट अपॉन इनपुट। सही है ना? मतलब हाउ मच इनपुट यू आर गिविंग टू द डिवाइस एंड व्हाट एग्जैक्टली द आउटपुट यू आर गेटिंग फ्रॉम द डिवाइस। Am I right? ठीक है ना? So will you tell me what output you are getting from the device? यहाँ पे देखो previous screen पे, what output you are getting here?
Work done.
Work done. And what input you are giving?
Heat.
Which heat? Q2 or Q1?
Q1.
Q1. And what is the loss in this process?
Q2.
Q2. ठीक है ना? तो यहाँ पे देखो, here we are giving input as a Q1 and we are getting output as a W. ठीक है? So here we can write, but W is nothing but Q1 minus Q2. So it will come Q1. So how to define this? What is efficiency? Because here W we know that Q1 minus Q2. ये देखो यहाँ पे भी हमने लिखा था अभी just now. See, this is Q1 minus Q2 is the work done, total work done. ठीक है ना? So how do we define efficiency? So यहाँ पे आपको कैसे डिफाइन करना है? देखो efficiency को,
Or work done per energy
yes, it is
absorbed.
ratio of It is the ratio of net work done by the heat engine. I repeat, net work done by the heat engine per unit heat energy absorbed by the heat engine. Clear? मतलब वो कितना वर्क डन दे रही है, कितना एनर्जी एब्जॉर्ब करके. अंडरस्टूड? Yes, get it? Is that clear? I repeat.
Yes, sir. सर डेफिनेशन रिपीट कर दीजिए.
हाँ हाँ लिखो once again. Efficiency यहाँ पे लिखना है आपको. It is the ratio of net work done by the heat engine, net work done by the heat engine per unit amount of heat energy absorbed by the heat engine. Amount of heat energy absorbed by the heat engine. Clear? Yes, get it. Is that
Yes,
clear?
sir. Yes, sir.
Okay, chalo. So we'll stop here. I'll share video also. Okay, I'll show you the video also. So dekho, I'll stop the screen now. Can you see this page now, bachcho? Can you see this page? Okay.
Yes, sir.
Okay. Now see, I'll play one video, 5-minute video. Just give me 1 second. Right on.
This concept you study about cyclic
Audible?
process and heat engines. Cyclic
Yes, sir.
process. A cyclic process in which the system, after passing through various stages of pressure, volume and temperature, changes and returns to its initial state. A cyclic process consists of a series of changes which return the system back to its initial state. For example, a system consists of a gas at a pressure P, volume V, and temperature T. Let the system be subjected to a number of changes including isothermal and adiabatic expansion and compressions. In the final state, if the system has the same pressure P, same volume V, and the same temperature T, the succession of changes involved are said to form a cyclic process. Heat engines. A heat engine is a device which converts heat energy into mechanical energy. For this, a system is made to undergo a cyclic process. A heat engine essentially consists of 3 parts. 1. Source of heat at higher temperature. 2. Working substance. 3. Sink of heat at lower temperature. The work done by the working substance of the system in a cycle is transferred to the environment via some arrangement. For example, when the working substance is in a cylinder with moving piston, the piston transfers mechanical energy to the wheel of a vehicle via a shaft. The cycle is repeated again and again to obtain the desired useful work for some purpose. If Q1 is the amount of heat absorbed by the working substance from the source at T1 K in one complete cycle, Q2 is the amount of heat rejected to the sink at T2 K in the cycle, and W is the net amount of work done by the working substance on the environment in a cycle. Net amount of heat absorbed dQ is equal to Q1 minus Q2. As the working substance returns to its initial state, the change in its internal energy is 0. That is, du is equal to 0. According to first law of thermodynamics, dq is equal to du plus dw. dq is equal to dw. That is, net amount of heat absorbed is equal to external work done by the engine. Q1 minus Q2 is equal to W. Thermal efficiency of a heat engine is defined as the ratio of net work done per cycle by the engine to the total amount of heat absorbed per cycle by the working substance from the source. It is denoted by eta. Eta is equal to net work done per cycle W by total amount of heat absorbed per cycle Q1. Eta is equal to Q1 minus Q2 by Q1. Eta is equal to 1 minus Q2 by Q1. As some heat is always rejected to the sink, Q2 is equal to 0. Therefore, efficiency is always less than 1. That is, thermal efficiency of a heat engine is always less than 1. For Q2 is equal to 0, eta is equal to 1, is equal to 100%. That is, the heat engine will have 100% efficiency in converting heat into work. Thus, first law of thermodynamics does not rule out a heat engine with 100% efficiency. However, practical experience shows that efficiency is less than 100% even sorts of losses associated with actual heat engine. Types of heat engines. 1. External combustion engine, in which heat is produced by burning the fuel in a chamber outside the main body. Steam engine is external combustion heat engine. 2. Internal combustion engine, in which heat is produced by burning fuel inside the main body of the engine. Petrol engines and diesel engines are internal combustion engines. They are also called four-stroke engines. Theoretical value of thermal efficiency of internal combustion.
Hello. Yes, cadet, am I audible?
Yes, sir.
So here one more elaboration I want to give explanation. कि external combustion engine, like for if you take the example of steam engine, तो उसको external क्यों बोलते हैं पता है आपको कि somewhere मतलब at one part means in boiler the water is being heated and the steam is being produced and then that steam is being passed through the pipe towards the cylinder and then cylinder works, cylinder does the performance, work done, mechanical work. ठीक है? So combustion of the fuel and cylinder both are the separate entities here, both are the separate things in external combustion engine. But if you see the internal combustion engine, everything happens inside the cylinder. फ्यूल भी वहां पे आता है, स्पार्क भी वहां पे होता है, एक्सप्लोजन वहां पे आता है, हीट भी वहां पे जनरेट होती है और मैकेनिकल वर्क डन वहां से जनरेट होता है. So did you understand what exactly the difference between internal combustion engine and external combustion engine? क्लियर हो रहा है? यस बच्चों.
सर.
हाँ बोलो.
सर वो तो पिस्टन तो पूरी बंद होगी ना सर, उसमें वायर कहाँ से जाएगा सर?
पिस्टन पूरा बंद नहीं होता बेटा. You must have seen. यहाँ पे देखो. You must
The
have.
system consists of a gas at a pressure P, volume P, and
If you
P,
see it, ये देखो पूरा पिस्टन बंद कभी भी नहीं होता. If you see it once
number
again.
P, and temperature T.
See, यहाँ तक क्या आ जाता है वो? Clear? Because there is always scope for air, fuel, and spark. Can you see it? और यहाँ से ऊपर जाता है. Understood?
Yes sir.
चलो. Thank you. Hope you and one more thing I forgot to explain. Efficiency is always less than unity. Why? इसका reason मैं यहाँ पे लिख रहा हूँ. देखो इस screen पे ही. I'm writing here only. Why efficiency is always less than unity? I'll tell you. ये देखो. The reason why efficiency is always less than unity, because efficiency का formula क्या होता है? If you see, it will come like this. See, eta is equal to net work done upon amount of heat energy absorbed, means Q1 minus Q2 divided by Q1. Okay, means Q1 amount of heat energy is absorbed and Q2 is rejected toward the sink. Okay, that is the reason why it never comes 1. In order to get it 1, you must write Q2 is equal to 0. Are you getting my point? If Q2 is equal to 0, means no loss at all. वहां पे heat loss नहीं है, silencer से heat आना ही बंद हो गया, and at that time efficiency will be 1, means 100%. But actual efficiency of the heat engine, diesel petrol engine, is 52% only, cadets, around 52%. मतलब जितना heat energy absorb करता है, out of that only it could manage to convert into mechanical work done 52% only. Understood? Yes, cadet?
Yes, sir.
Okay, chalo, we'll stop here now. Hope you enjoyed today's class. Chalo, thank you.
हेलो.
हाँ, yes, yes.
एक्सटर्नल कंबशन इंजन का समझना है.
एक्सटर्नल कंबशन इंजन मींस व्हाट? फॉर एग्जांपल स्टीम इंजन, उसमें क्या होता है बेटा कि दो चेंबर होते हैं, अलग अलग होते हैं, मतलब एक चेंबर में पानी को गर्म करके फ्यूल को बर्न करके, फ्यूल कंबशन एक यूनिट में होता है, पानी गर्म होता है, उसका स्टीम बनाया जाता है, एंड देन स्टीम इज पास थ्रू द पाइप टुवर्ड्स सिलेंडर, और वहां पे सिलेंडर से पिस्टन जनरेट होता है, मतलब मैकेनिकल एनर्जी क्रिएट की जाती है। तो इसलिए बोलते हैं एक्सटर्नल कंबशन, उसका कंबशन इंजन के बाहर होता है। एंड इंटरनल कंबशन मींस व्हाट? लाइक डीजल इंजन, उसका कंबशन इंजन के अंदर ही होता है। अंडरस्टूड?
Yes, sir.
ओके, चलो, थैंक यू।
थैंक यू सर।